Have you ever driven past one of those massive oil refineries? You know, the ones with all the pipes and towers, and just thought, how in the world does that all work together? I mean, these are billion-dollar projects with thousands upon thousands of parts all moving in perfect sync. Well, today, we're going to pull back the curtain and deconstruct the secret language that keeps it all from turning into total chaos. So that's the big question, right? How do you possibly control that level of complexity, where just one tiny mistake could have huge consequences? It's like a puzzle on an absolutely epic scale. And the solution? Well, it's not some magic supercomputer. It's something much more fundamental. And there it is. The secret sauce isn't one single thing, but a whole library of incredibly detailed technical documents. You can think of them like a set of nesting dolls. Each document fits inside the next, adding another layer of detail, creating this invisible but totally unbreakable blueprint for the entire project. So let's start peeling back the layers. Okay, so just like building a house, you don't start by picking out doorknobs. You start with the master plan. You need that big picture view, that map of the entire system, before you can do anything else. And in this world, that master plan is called the P&ID. That stands for Piping and Instrumentation Diagram. And honestly, this is the absolute bedrock of the entire project. It's a drawing that shows every single piece of the puzzle and exactly how it connects to everything else. Now, I know, at first glance, this just looks like a crazy mess of lines and symbols, right? But it's actually an incredibly precise map. It shows every pipe, every valve, every motor, every single sensor. This one document is the single source of truth that every single engineer on the project, mechanical, electrical, civil, will come back to again and again.
All right, so a map is great, but a map alone isn't enough. Imagine a map of a city with no street names. You also need a detailed inventory, a complete list of everything on that map. And that brings us to the next layer of our blueprint.
And you really have to think about this. That P&ID we just saw, it can have thousands of little symbols on it. So how on earth do you manage all of them without losing your mind? How do you know what each of those little circles and squares actually is in the real world? Well, you do it with this, the instrument index. If the P&ID is the map, then the instrument index is the giant, searchable master inventory list. It's basically a massive spreadsheet that gives every single component its own unique name and identity. So here's how it works. Every instrument gets a unique tag number, kind of like a serial number. And that tag is then linked to all the critical info, what it is, what type of instrument it is, where it's physically located in the plant, and, this is super important, which P&ID drawing you can find it on. That little cross-reference is the magic that holds the whole system together. But, you know, we're not done yet. Not even close. We've mapped the plant, and we've listed out all the parts. But a simple list doesn't tell you the really important stuff. What are the nitty-gritty technical specs? We need more detail. And that's where this comes in, the instrument data sheet. For every single tag number in that giant index, there's a data sheet like this one. This is the technical resume for the part. It's got everything, the pressure it can handle, the temperature range, the materials it's made of, the accuracy required, every single detail needed to make sure you buy the exact right component for the job. So let's recap. We've got our map, we've got our detailed parts list, and we've got the specs for every single part. What's next? Well, now we need the assembly guide. How do all these individual pieces actually get installed and wired together so they can talk to each other? This is where two more super important drawings come into play. Over on the left, we have the loop diagram. That's the electrician's guide. It shows every wire from the instrument in the field all the way back to the main control system. And on the right, you've got the hookup diagram. That's for the pipe fitter. It shows them exactly how to physically mount the device and connect all the little pipes and tubes to it. You know, this is such a great way to think about it. The loop diagram is basically the plant's nervous system. It carries all the electrical signals and information. And the hookup diagram is the plant's skeletal system. It's the physical structure that holds everything in place. You absolutely need both of them to make an instrument work. Okay, so everything's installed and connected, but how does the system actually think? How does it know what to do if something goes wrong? That logic, that brain, is all mapped out in yet another document before a single line of code is ever written. This right here is a cause and effect chart. It's a simple but powerful matrix. It basically says, if this cause happens, like say the pressure in a tank gets too high, then these effects must automatically happen, like an alarm goes off and a safety valve pops open. This chart literally becomes the rule book for programming the entire plant's automated safety systems. So, we've designed it, we've documented it, we've created all the assembly instructions, we're in the home stretch now. But this next phase, making sure it all works perfectly and safely in the real world before you flip the switch, is maybe the most critical of all. All right, 3 huge things have to happen here. First, you have to classify all the hazardous areas to make sure you're using explosion-proof equipment where you need it. Second, you have to commission the plant. That's a fancy word for doing a ton of on-site tests to prove that every single switch, valve, and safety system works just like the drawings say it should. And finally, and this is so important, you update all of the drawings to show how the plant was actually built, because things always change a little bit during construction. And that last step, creating the as-built drawings, is absolutely non-negotiable. These documents become the new Bible for the plant's entire life. For the next 30 or 40 years, every time someone needs to do maintenance or troubleshoot a problem, they're going to rely on these drawings being a perfect, 100% accurate record of what's actually out there. So, from that first giant P&ID map down to the instrument index, the data sheets, the loop diagrams, and the safety charts, you now see it, right? It's this incredible and visible web of documents holding the whole thing together. It's just proof that meticulous planning and crystal clear communication aren't just boring paperwork. They're the secret ingredients that manage unimaginable complexity and keep our world running.